everyone. Today we're going to look at compound interest. So the compound interest formula is the following: S equals P times 1 plus R over M to the MT. It looks a little bit complicated, but we're going to break it down piece by piece. So S is the compound or future amount. So it's the amount in the bank after the interest has been applied. P is the present amount, also called the principal. It's the amount that you deposit into the bank account. R is the interest rate as a decimal, so you're given it as a percentage. You always have to make sure you change it to a decimal first. M is the number of times the interest is compounded in a year. So you'll always be given something like 3% interest compounded monthly. So then you ask yourself, how many times does a month occur in a year? So M would be 12. If the interest was compounded quarterly, M would be 4. There are 4 quarters in a year. Okay, so you're going to be given it as a word, and you have to translate that into a number by saying how many of those occur in a year. And then lastly, T is the number of years the money is earning interest. So how long did you leave the money in the bank? There are 2 types of questions we can ask. What is the compound amount and what is the present amount? So we're going to start with the compound amount or the future amount. So you deposit $5,000 into an account earning 3% interest compounded monthly for 8 years. How much is in the account after? And also, how much interest did you make? So how much is in the account after? That's in the future. So we're looking for S. So we got to plug all our numbers in. So I deposit $5,000. So that's P. The interest is 3%. And I have to change that to a decimal. So that's going to be 0.03. 8 is the years. So that's T. And then compounded monthly. Again, there are 12 months in a year, so M is 12. So once we figure out what each letter represents, I'm going to plug it into the formula. Whenever possible, simplify as much as you can before you plug it into the calculator, but you have to be careful. There is absolutely no rounding until the very, very end. Okay, at the end, we have a dollar amount. So we have to change it to 2 decimals, but that's only at the end. There's no rounding in the middle. It's very, very important that you do not round in the middle. However, I can simplify it. 0.03 divided by 12 is exactly 0.0025. I didn't round. It's exactly 0.0025. There are no decimals after that 5. And then 12 times 8 is 96. So always do the exponent first, because a lot of people will forget to put that in parentheses if they're shoving it into their calculator. So I'm always going to do that part separately. And then if I can, I'll do out the fraction. But again, if that fraction is something that repeats, I have to leave it as a fraction. I cannot round it. And then I plug this into my calculator, and I should be getting $6,354.34. So I want to make sure you're actually doing this out. So have your calculator in front of you, do it out, make sure you're getting the same answers. The interest is the difference between what I put in and what I can take out. So that's S minus P. So S is 6,354.34. P is 5,000. So I subtract, and I get $1,354.34. One thing to make sure of is that S is always bigger than P. Right? What you get out at the end is what you put in plus the interest. So S has to be bigger than P. How much would you have in the account if the interest was compounded weekly instead? So the only thing that's going to change now is M. So M is weekly. How often do we have weeks in a year, or how many weeks are in a year? And that is 52. I have a lot of people who tell me 7. There are 7 days in a week, but I need how many weeks are in a year, which is 52. So that's going to change my M here and here. M is the only variable that we use twice, so be careful, make sure you're changing both of them. 0.03 over 52 is some crazy decimal, but again, I'm going to at least do 52 times 8 before I plug it into the calculator. So I plug this in, and I should be getting $6,355.81. It's not much of a difference, but it is a difference. The more often you compound, the more money you're going to make. So if I compounded daily, I'd get even more money. If I compounded hourly, I'd get even more money. Okay, so the more often you compound, the larger your future value should be. So let's try another one. You deposit $800 into an account that earns 2.35% interest compounded daily. We're going to assume 365 days and not worry about leap years. Find the amount in the account after 10 years. So I'm going to plug in all my numbers. So again, 800 is P. That's the amount that I'm depositing. My interest rate, make sure you put it as a decimal, so 0.0235. 365 days, again, M goes in there twice, and then the time is T, which is 10. And the only thing I'm going to simplify is my exponent. 0.0235 divided by 365 is something really terrible. It's not something nice, so leave the whole thing in there. Plug that into your calculator, and you should be getting $1,011.92. How much would you have in the account after 20 years instead? So the only difference is my 10 becomes 20. So again, my exponent is now twice what it was. And I should be getting $1,279.98. So if I look at it, if I go back to the first one and I want to find my interest, I'm going to take my S and subtract my P. So I get $211.92. If I find my interest in the second one, I have $479.98. So I've doubled the amount of time my money is in the account, but I've more than doubled my interest. And if I had just simple interest instead of compound interest, my interest would be exactly doubled. But with compound interest, you get more, which is better. So again, this is more than twice. So that's something to keep in mind. Suppose you want to save up some money. After 5 years, you want to have $4,000 in your bank account, and that bank account earns 4% interest compounded monthly. How much should you deposit? So how much should you deposit is P. After 5 years, you want $4,000. So that's the future amount, the amount that I want after the interest. So the question is, how do I solve my equation for P? So what I do is I take my original equation and I want to get P by itself. So I divide and I bring this guy over. But when I'm dividing by something with an exponent, remember I can rewrite that as multiplication as long as I take my exponent and make it negative. So this is generally how you're going to see the equation. You divide by what's in the parentheses and the exponent, and then you change it to a negative exponent so that it's still multiplication. Okay. So what it looks like is I've switched my P and S, and I've made my exponent negative. And then again, I'm going to plug everything in. We said 4,000 is S, 5 years is the time, 4% interest as a decimal, 0.04, and then again monthly, so M is 12. And don't forget the negative. I'm going to simplify as best I can. 12 times 5 is 60. 0.04 over 12 is a repeating decimal. So again, you want to make sure you have that whole thing in there. My answer is $3,276.01. Notice it is less than S because now I'm looking for P, and S is always the bigger one. how much would I make in interest? So again, it's S minus P, but now, again, S is the thing I was given, P is the thing I found, which is the reverse from before. So just make sure you're taking the bigger one and subtracting the smaller one. And we get $723.99. So let's try another one. Suppose you want to have $500 at the end of 2 years when depositing into an account paying 5% interest compounded quarterly. How much should you deposit? So again, how much should I deposit? That's P. So 500 is the S, 2 is the time, 5% as a decimal, 0.05, quarterly, again there are 4 quarters in any whole thing, so in particular there are 4 quarters in a year. I'm going to simplify. 0.05 over 4 is exactly 0.0125. No more decimals after that, I did not round. 4 times 2 is -8 for my exponent. Plug this into my calculator, and I get $452.70. So again, notice that P is smaller than S. And for the last one, suppose you want $10,000 at the end of 4 years when depositing into an account paying 3.5% interest compounded weekly. How much should you deposit? So again, how much should you deposit? I'm looking for P. S is 10,000. 4 is T. 3.5% as a decimal, 0.035. Compounded weekly, again there are 52 weeks in a year. I'll simplify my exponent and then plug it into my calculator, and I get $8,693.99. Again, less than what I want at the end, which is 10,000. Okay, so this is really a lot of can you plug it into your calculator correctly. So I really want you to make sure that you are trying it out on your calculator and that you're getting the correct answers. So read through the book, try out some of the homework, and let me know if you have any questions. Thanks.